How could one interpret Galileo's inclined plane experiment in terms of energy? I'm going to go ahead and look at what the slide says for this because it's going to toggle for us a series of pictures that are going to answer this question. You might recall that Galileo's inclined plane experiment had something to do with inertia, and I'm specifically talking about the sort of double inclined plane experiment where you start an object at rest. It's there at a certain height. Now this question though said in terms of energy, so let's see what happens, because it's saying there, well, initial energy, the type of energy it can be thought of as having for being some height above, say, a floor or just some reference height, is gravitational energy. So that's another one of the energy types. There's in that sense a score value, you could say, associated with being some height above the ground. And of course, to do that, you need to establish what ground means, and that could be different for different situations. One of the idiosyncrasies of gravitational energy there. But again, this problem is kind of a preview for how we're going to think about energy later on. So some of the formulas are mentioned there. It says weight times height, which could also, we know that weight is equal to mg, so we're going to use mgh later on for that. Anyways, it rolls down the incline. We've seen that before. We said, hey, it's going to have inertia down there. But from an energy perspective, in the language of energy, you could say it has a kinetic energy. And we just saw a moment ago that there was a living force concept that Leibniz had come up with early on in history. But later on it was discovered, specifically in 1847, the discovery was made that maybe 1/2 mass times speed squared is a better formula, and that turns out that can be based on forces, why that has to be there. And Leibniz was missing the 1/2 part of that. But basically, from an energy point of view, what's happened is our interpretation of the ball rolling down is it started with some amount of gravitational energy, it rolled down, and now it has kinetic energy. And if there was no friction, all of that gravitational energy is now turned into kinetic energy. So we're definitely still thinking about this without any drag forces. When Galileo did this experiment, he tried to remove drag as much as possible. And for what I'm saying here to make sense in terms of these energy forms, that has to be there. Now, does that mean that you can't apply energy concepts to situations with drag forces? The answer is no, you can do that. It's just when there's drag forces, there's usually also heat produced, and that brings in thermal energy as one of the other energy types, and that one doesn't have quite as simple a formula for it, so it tends to be a little less useful perhaps to use in that sense. But here we're saying, okay, like it rolled up to some height. One of the big aspects of this experiment that Galileo discovered, well, experimentally, is that the ball, in the absence of drag forces, always rolls up to the same height. From an energy perspective, that makes sense because it went from gravitational energy to kinetic energy back to gravitational energy. If it's going to have the same amount of gravitational energy where it winds up, that depends specifically on its height. So it makes sense that it should return to the same height. And of course, there it is, a return to the same height. And if we do that with a different incline, so now the second incline is a little less steep there, right? As you can say, it starts at rest, same as before. It's going to have gravitational energy, same as before. It's going to have kinetic energy right there. We're just going to go through that though. It's going to stop there and be at the same height because, again, same amount of gravitational energy. As long as there were no drag forces and thermal energy being produced, then that would represent kind of maybe an energy loss to this system as we're looking at it. The total gravitational energy it winds up with is the same as it started with, and therefore, again, it goes to that same height.